Hey everybody, this is Larry. This is Friday the 13th. Well, okay, I lied. Because yesterday was. Well, I'm doing day 14 of the September Leetcode Daily Challenge. Hit the like button, hit subscribe button, join me on Discord. Let me know what you think about this one. But today here in New York City is Friday the 13th. So it's a little bit, I don't know. Nothing that weird happened today. So that's good. In a good way. I went to the gym, did some benching and just a lot of stretching and kind of mobility work, and then I went 5 miles. So a pretty easy day, pretty lazy, easy miles. Kind of keep it at low key. So and tomorrow as well, just like 8 miles easy, as they say. Hopefully, yeah, just kind of stay in shape until the marathon hits, which is in I don't know anymore, like a little bit over 40 days or something. So yeah, let's take a look at today's problem without Larry talking about everything. Today we have 2419, longest subarray with maximum bitwise n. You're given an integer array nums of size n. Consider a non-empty subarray from nums that has a maximum possible bitwise n. Okay, maybe. I don't know if I know what that means yet. I mean, I read the words, but I don't know what that means yet. Okay, anyway. Oh, there's a... In other words, let k be the maximum value of bitwise n of any subarrays of nums. Then only subarrays of a bitwise n equal to k should be considered. Okay. Return the length of the longest such subarray. That's a really weird way of phrasing it. Basically, you want the longest, or like you just want the maximum value of the bitwise n and tie break by the longest subarray, but you want to return the length, I guess, instead of the amount. Okay, so fine. The bitwise n. Okay, yeah. Subarray is a contiguous subsequence of elements in an array. Okay, so I mean, first thought of course is n squared, just because why not, right? But taking a look at n is 10 to the 5th, and that's not going to be Gucci. No bueno. So okay, let's take a think, right? Okay, so what do we know about bitwise n? Bitwise n has this property where well, I mean, okay, so I mean, we talked about bitwise operations the last couple of days, just because I guess that's the theme these days, right? And basically the idea, the first thing, of course, is just kind of truth table, always truth table. If you haven't done it enough, then just truth table it, right? So you have this, right? But and then it's just to think about, okay, so you have this truth table which anyone can write, right? With some practice, I suppose. And then now we want to try to maximize numbers. So then now, I think it should be obvious. Well, I don't know. Actually, I wouldn't go that far. I don't know if it's obvious, but I think the first thought that I had anyway, whether it's obvious or not, is that when you add two numbers, you're always going to get a number that's smaller than both of them, right? Or equal to or less than both of them, right? Because if you look at this, which is why I write it out, okay, if they're both ones, then you have 1. In every other scenario, you get a 0. And of course, like I said this yesterday, so definitely maybe check out yesterday's video as well. Hopefully you've been doing this all week anyway. On Friday the 13th. Oh, I forget that this is technically the 14th. Okay, whatever. But the thing is that, yeah, if you add for a bitwise operation, all the bits are done in parallel, right? Meaning that, for example, if you have, say, I don't know, 19. Okay, whatever, right? 19 is just 16 plus 2 plus 1, right? So what is that? I don't know. 16 plus 2 plus 1, right? Something like that. So then now, these are the bits, the binary bits. I'm too lazy to count them out. But then now you add it with another number. Well, what happens? Or not if you add it, but if you bitwise add it with another number, what happens? Well, all the stuff that it is 0, so I don't even know what it is. So maybe it's like something like this. I didn't count, so maybe I'm off by 1. Maybe something like this. Maybe it's off by 1. Whatever, right? So you have this number, this binary number. I don't even know what it is. but it's this binary number. So you want to end it with another number. What happens? Well, the zeros, you already know that this is going to be zeros and the end result, right? So we want to end some number. We already know that the three things in the middle are zeros, and the best you can do with the rights and the lefts are ones, and that, of course, to get this, it has to be either the same exact number or even just a lot of ones, right? And of course, if you have a lot of ones, you can say that, well, this is no longer max, right? So you want, you know, in this case, this got smaller, right? So, you know, yeah. So that's basically the idea. And once you kind of play around these ideas, you'll notice that whatever you do, if you end two numbers that are not the same, you're going to get, the answer is going to be smaller, right? And here we want the maximum possible bitwise n. So without loss of generality, we'll say that A is always bigger than B. In that case, if A is always bigger than B, then we bitwise n them, it will always be less than A unless B is equal to A. And in that case, it is only A, right? So it's less than or equal to. This is a long way to talk about it, but it also means that the maximum bitwise n, or the bitwise, the largest value that you can get for this operation is just the maximum number. Because any number with a bitwise n of another number is going to be smaller. So then why, right? So therefore now you have the max number. So max is equal to maximum nums. So we have the maximum number, and all we have to do is to try to figure out the longest sequence of it, because the biggest number is going to be the maximum possible bitwise n, and then now we have to find the longest subarray, right? So here then we just count by the longest subarray, right? So here maybe we have a streak is equal to 0 for x and nums, and maybe I mean you can write this in a lot of ways, right? But I'm just, you know, if x is equal to max, then streak L streak is equal to 0, best is equal to max best streak, and you can actually put this only on the plus because, you know, yeah, okay, yeah, quick submit, hopefully this is right, yeah, yeah, that's all I have for this one. Let me know what you think. Yeah, I mean, when you look at the code, maybe it's obvious, maybe it's not, but hopefully, you know, this is, I explained my thought process and how to kind of get to it. And I think at the end, I mean, yeah, the solution is maybe a little bit silly, maybe it's a little bit whatever, but the process, you know, if you're not, you know, I wouldn't try to memorize anything or whatever, but if you are able to understand and reproduce the process, then it should not faze you. I don't know how I did in the. I'm curious whether this was during a contest, and whether I did well. I mean, you could probably watch this video, right? Oh, I just did it this way, but I did do this during a contest. How did I do during this contest? Dun, dun, dun. Ah, that's well. Josh won this one, so good job, Josh. What is this? Is this new? Is there a way to get the old one back? What is this new dark mode thing? I don't want dark mode. If I want dark mode, I would have asked for dark mode. Alright, but I'm 80 seconds. I guess I did okay. Which one is this one though? Is this a Q2 or the Q3? Yeah, that was the Q2. So I end up doing this for about in 1 minute. I guess I have a penalty on this one. I don't know. Either way, yeah. I have to figure out how to turn off dark mode. I don't know. Some people like it, that's just not me. Whatever. What's the complexity here, right? Should be obvious, hopefully, or like, you know, you should go over it. This is linear time, or linear iterations, each with constant time, so this is linear time. So linear time, constant space, we have constant number of variables, and that's what we have all we have for this one. Let me know what you think. Thanks for watching. Yeah, stay good, stay healthy to your mental health. Have a great weekend, everybody, and a good Friday the 13th. I'll see y'all later and take care. Bye bye.